Okay, so for those that are taking a test, we just started off with graphing, and then we said over and over and over again from yesterday, let's just get, what are we doing today? I said, this should be no problem from yesterday's notes. This should be no problem and should be something you already know how to do. We're going to do this right now. We haven't done it yet. And we should know how to graph exponential functions through transformations. So I didn't get to talk to you because I forgot to start the video on graphing these. But the last one, what did we say? There was an x-axis reflection, right? And then this moves 3 to the what? Right. And then this moves what? 5 down. And then you graph it accordingly and answer these questions. I hope you know how. I hope that helps. Is it frozen? Oh, for the love of God. But it's not frozen on my screen though. That's being taped. Good call. Okay, but it actually is okay here. All right. So, anywho, now we're gonna do this. All right. Do you see it? Everyone knows this, right? If 2 to the x equals 2 to the 7th, what does x have to equal? Come on. 7. Here I could write this down too. What's LO6? Does anyone know what that actually is? I had one student in Algebra 2 Honors 3 years ago. After a month of doing the log chapter, on day 31 he asks, what's LO6 mean? The whole chapter. The whole chapter. Isn't that unbelievable? Anyway, what does x equal? You don't even have to know what logs are. I could show this to my seven-year-old. She's not in 7th grade in 7th. But what's x equal? You don't even have to know. Who's a sinner? There's a sinner in here? What's x equal? You don't even have to know anything about trig to know that x equals 12 for that. Do you get it? Okay, so this is sure. I always love that. Or sure or whatever. Right? So, do you know what we're going to do for this? This might be on our little no calculator experience. And base, you know what I did with those previous graphs? There was no calculator involved. There was knowledge. Some people are obsessed with their calculators, and that's why they can't do enough without their calculator. They need to be able to do more. This is no calculator solving. Remember what I said now. The book is not great with their notations. This is terrible. This almost looks like 2 times the quantity. No, this is an exponent. And get used to it. That this book is terrible with we're in the exponential chapter. So that's 2 raised to that power. So how am I going to do this without a calculator? Well, it has to do with this. I want to get it to look like this so it's an easy assessment. We didn't do anything mathematically with the 2's. We just did a comparison. Well, if 2 to the x equals 2, then these have to equal. It's very simple. So what I have to do to this is 2 to the 7 minus 3x equals, 2 to the blank. And this is an equation, so I can't change its value. I just got to fill in the blank that's true. And I know half you already know the answer. 2 to what power equals 1/4? So this has to be the same. This is no change in the equation. That's what people screw up all the time. All they did is make a change in what it looks like, but this is mathematically equivalent to that, so I may change that and may do that. And now I did not do anything with the 2's. All I'm saying is, if 2 to this power equals 2 to that power, I got these bases to be equal. The only way this is true is if this power equals that power. I didn't divide by 2. I didn't use logarithms. By the way, you could use logarithms to solve that, but I'm going to pretend you don't know what those are. Is that a good pretend? Do you know how to deal with logarithms right now? Well, it's usually, even if you saw it last year, I'll be honest with you, you need to see that 2 years. That's a little weird stuff for students for the most part. Subtract 7, and then divide by -3. Now, I can prove this. What's 3 times 3? See, I'm going to plug in 3 for x and make sure that it works. Good FOILers, good factors. Check your answers. 3 times 3 is what? 9, Mr. Samuelis. What's 7 minus 9? What's 2 to the -2nd power? And this goes back to the bell work that I gave you yesterday. These are things that you better know how to deal with going into this section. That's why we did this little thing. These are things that are expected that you are experts on so that you can deal with these exponent scenarios. All right, so again, that's good to bring up for those that didn't watch the video yesterday, which was most of my second hour. By the way, second hour, I just found out someone in third hour watched the video, so your number of people that watched that video was down one. So it's even worse. So even though you're not in third period, you're still getting yelled at, just like in the notes today. Anyway, are you okay over there? What is this going to be? What is this going to be? Come on. By the time I'm writing that 3 down, someone tell me the power. Did you say 4? Oh. Oh. It's negative. And which one is it? -3 or -4? 4. And then the people that are not numerate enough are like, what? What's 9 times 9? By the way, live long and prosper. Anyone? Spock? No one knows Spock anymore, do they? Never mind. And people on the video have no idea what I'm talking about. What's 3 times 3? Or, I'm sorry, what's 9 times 9? 81. What's 9? 3 times 3. 3 times 3. How many 3s do you see in my hand? 4. Okay, so it is 3 to the 4th, but it's 3 to the -4th. By the way, what's x equal? 4. Right? And then if I plug in a 4, 3 to the -4th is 1 over 81. That's too easy. What did I make up last hour? I don't. It doesn't have to be anything special. 5 to the 2x. Ooh, we're going to get nuts. This is going to even be better than last hour's question. Equals, oh, you're going to be so mad at me. 1 over 25. I have no idea how this answer is going to shake out because I'm making this up. Raised to the x plus 2. What? Okay, well, the first thing is I got to get these to be equal bases, right? So who would be easier to change? It would be easier to change 5 to be 1 over 25 to a power, or to be easier to change 1 over 25 to be 5 to a power. 1 over 25, and I have people do that weird other thing. It's possible, but this is much easier. 5 to what power equals 1 over 25? Okay, again, I told you I don't even know how this is going to work out for an answer, but it will work. 5 to the -2 raised to the x plus 2. And then again, I think I closed those notes. This came back to the bell work from yesterday. Some things you're expected to know. Yes, you do what with these powers? Okay, but now, again, you're not doing anything mathematically. You're just saying if 5 to this power equals 5 to that, the only way this is true is if this equals that. So 2x minus 5 should equal -2x. Let's go ahead and distribute now. I'll be curious. Oh, I got scared for a second. By the way, if these would have canceled, then it would have been no solution, but just talking out loud. 4x, add 5 to -4, and you get 1, right? So x equals 1/4 power. Or x equals 1/4, then you'd have to plug it in. Now, let's be honest. When I plug this in, it'd be tough to check that because, then you got some fractions in the exponents. But it would check out. Just have to trust me, okay? And we won't do that on that. All right, I'm going to take a break for a second. I may have assigned this, and it's an inequality exponential scenario. And I don't even think I want to look at it this way. So solving this inequality, let's just think about some numbers. What's 9 to the 0 power? What's 4 to the 0 power? So could x equal 0? Would that solve this? No. But what happens when we start getting bigger than that? Like what happens when I plug in 1? Isn't 9 greater than 4? All right, what happens when I plug in -1? What does this become? So x equals -1 is not true because this becomes 1/9. Is 1/9 greater than 1/4? No. Okay, so actually, right when we increase, right when we get past 0, then this starts getting bigger than this. Or what you could do is look at these graphically. You could graph this and see the intersection. By the way, we should know that they intersect both at what? What point do these both graphs intersect at? 0, 1. Which one do you think is the 9 to the x graph? The purple or the red? You should know it's the purple because it's a bigger base. So notice after 0, 1, these y values are what compared to the red y values? Greater. All right, so that'd be another way you could do it. This was another way, subtracting 4 to the x power and getting one graph, and then analyzing when that graph is greater than 0. So a lot of different things we've done this year. I know I went over that fast, but it should be something we could be able to figure out. And then all we have is one more example, third hour. And we'll take a break, and I got to get ready for that. Hey, remember this example? Well, that's because you had your desk turned now. I just got you turned the right way. Because we did this yesterday. Oh, it's frozen again. Shucks. Do you remember this example? I'm sorry. I'm so mean today. Hey, is it hump day? Yo, 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 what day is it? All right. You guys don't remember that? Remember, whenever you see the word exponential function, remember? You yank out this formula. Okay, back to what are we going to learn today? And I was worried about this. I got rid of that. Darn. But what is, whenever you see exponential, you deal with this formula here. What's the initial value? What's the initial value for this question from your notes yesterday? Come on. 0, comma 12. So the initial value is actually 12. And then I told you could pick any other coordinate on this to find what b is. But the easiest one is 1, comma 4. So because when I plug in x, 1 for x, that's just b to the first, which is b. And then 4 for y, all I have to do is divide. And then this formula actually matches this chart, which I accidentally... Okay, just remember that? Okay, I was worried about that most because that's what we're going to end with today. And what you got to do is trick yourself that the next example you're going to see is exactly like... It's actually more like this one, because how many points do you have on this next one? 2, and we went through that one yesterday. So we only have 2 coordinates. Because now, if you can do that, this question is 100% the same. Sorry, I should show the question. Oh, I forgot to erase one more thing. Bummer. Hopefully you didn't see that, but go ahead and read. Using the data in table blah, and assuming the growth is, everyone say that word. Stop! And you pull this out right away. Immediately. But all I did after that is they might throw this in there, and it's really not a difference. The initial value is the initial population in a population times some growth or decay factor. Populations can go down actually sometimes. B raised to the x equals the population over time. So I don't know. It's just a rewriting of the basic formula for exponentials. Now, what did I just erase? Well, we're doing Columbus, Ohio, and we want to know when will it surpass 800,000. What I need is a formula for it. Okay, so I look at Columbus, Ohio's data, and I say, oh, in 1990 it's this, and in 2000 it is this. How far is it from 1990 to 2000? 10 years. So what could I call this? I could call this I just said this word about a minute ago. So I'm going to make this a coordinate in my head. So I can take this table and say, okay, I'll take 1990 as year 0. And then any negative years would just represent years before 1990. So you could surmise what would the population be in 1980. Then you could plug in negative numbers to find that. That's what you should be able to figure out. Well, then that makes the 2000 population 10 years. Because remember, right at the start of January 1st, 1990, you're at year 0. Then at 91, in January 1st, that's the beginning of year 1, and so on and so on and so forth. So that's why it's definitely 10 for 2000. We're talking about January 1st, 2000. This is when the population is, hopefully that's how this works out. So what do I know then? What do I know? P sub t? Do I know P sub 0? Do I know B? What do I know right off the bat? P sub 0. And I don't care if I put f of x or P sub t. It doesn't matter. You should be able to handle this. I'm just trying to use population over time instead of f of x. Give it some more meaning. Because, again, if I plug in 0 for x and 600,000 for y, this is going to be b to the first, which is 1, or b to 0, which is 1, which means P sub 0 equals 632. And then I'll actually write this out. I kind of went over it real fast with the other R because we were running out of time. Because I had to cover things that they didn't watch in the video. Did I mention that? Raised to the times b raised to the x. Sorry. Now what do? Well, I do exactly what I did in this example. Boom. That's why I keep going back. And I don't have the notes here, but they're in yesterday's video. What did I do next? I plug that in to find what B was. So what I'm going to do is plug this in. And now we have our first little conundrum. But you know what? I bet you 95% of you know what to do on this. What do you do first to try to solve for B? Divide. And I'm going to be real messy on this. So I'm going to divide both sides by 632, which destroys this. Makes it 1, actually. Doesn't destroy it. That's such bad math. Some math people out there that are real sticklers on stuff. They'd be, oh, how dare you say that? And then what? How do I solve for B to the 10th? What'd you say? 10th root it. Now, I didn't show the other hour this because I was yelling at him all period. And then someone did in second hour say it out loud that there's an option for this. You could actually do one of two things. I'll show it on the 84. I don't remember finding an X-root button on an Inspire. I don't know where it's at. So where the X-root button is here is the math, and it's 5, and I'm already wrong. Clear. Because what I have to do is type 10 in first, then go into, not second, math, a little rusty on the calculator. That means the 10th root, and then it actually, since my calculator's upgraded, it throws it up in there. 10th root of, and then I could type this in, 711. I shouldn't have to write the rest of this. This becomes boring video. More boring than usual, let's say. 632, 910. Press enter. What did I just do? What happened? What happened? What didn't I do? What? Oh, yeah, what am I doing? It's like I'm typing. This is really good video. Oh, whew. Or all of that stuff, caret, I'm starving, 1 divided by 10. That's what the, that fraction raised to the 1/10th power is the same thing as a 10th root. Check yourself. Fumble. Or he viciously threw his paper on the ground in anger. It's one or the other. Okay, so now, notice what it said. And I hope you get this. I needed an equation for this. So, when you get a question that's similar to this, you got to come up with an equation, the same format that I just did here, and then use those equations to answer the questions. This one said, when will the population possibly reach 800,000 if this continues? Well, it's going to happen in the future. It's going to happen in year 12, 13, 15, 16, somewhere around there, right? You can see it going, moving up. Well, what you do is put this in Y1. I'm not even doing this in the graph. You should be able to handle this instruction right here. All I do is put my new equation I found for Columbus in Y1. And then I put Y2 equals 800,000. Because that's what you're solving for. Otherwise, you'd have to solve this equation. You'd have to plug in 800,000 for Y. 632, 910 times this 1.0117 raised to the x. But do you know what's definitely required to solve that? Starts with an L. Logs. So later we can come back to this and solve this through logarithms and not use the graphing calculator. But since I don't have logarithms yet, or at least we're not pros on it, we need to find the intersection of these two graphs. But let's just talk about this. What does this represent right here that what am I writing? What am I telling you right here? This is our what? That's our window. Now, did I go farther than I need to? Probably. At what year do you think this might happen? It might happen within 20 years, so I bet you 0 to 20 would have been fine for X. And then this really only has to be 800,000, but I want to go beyond that just to see the graph totally. So I want the window to incorporate everything and see that intersection. And then what am I asking for? The X or the Y value? The X. It's the number of years. And I don't know what it says. I forgot what it was, but blah, blah, blah. Then I'll end with this question. What does this number really mean, which actually goes into 3.2? What does that number really mean? Well, first of all, does it mean the population's growing or decreasing? Well, look at it. It's growing, right? Right? So this number, let's pretend that this was just 1. What's 1 raised to any power times 632,000? Any change? No, this is what 3-2 is all about. It's very simple. So what does this really mean then? This means it's growing at what percent per year? At, yes, say it. Oh, it's growing at 1.17% per what? I don't know why I put an R there first. Per, oh, this is getting bad. Year. And now we've actually started talking about 3-2. Because you really should understand that if this was 1 and nothing else, this would never change. If it's greater than 1, then it's growing. If it's less than 1, what's happening? It's decreasing, or what's called decaying. All right? All right. Done. I don't know why I just added that. I thought it was